Okay, now looking into a topic that if you were to take a course in differential equations, especially at the graduate level, um, I would recommend that you, to an extent, familiarize yourself with Fourier, especially the Fourier series. And we have within this realm of mathematics specialty, we have what are referred to as Fourier approximations. And for what we have here, okay, we have says here to consider functions of the form where we have g of x is equal to a naught over 2 plus a sub 1 cosine of x all the way out to a sub n cosine of nx. And then we have followed by b sub 1 sine of x plus b sub n times the sine of nx. Okay, and this is going to be in a subspace where we have the interval to range between 0 and 2 pi radians. And we have to be spanned by the basis. Okay, we have s is equal to 1 cosine of x, cosine of 2x, all the way out to combinations that we have up to cosine of nx and the sine of nx. And what we have with the variable n, that is going to be the order of what we have in the approximation. And it says here that these two n plus 1 vectors are orthogonal in the inner product space we have between 0 and 2 pi radians, because the inner product of what we have in f and g, okay, is going to be equal to 0, where, again, we have f and g are going to be distinct from each other. And now, again, so you have orthogonal where we have the product equal to 0. And let's say that for an orthonormal basis, okay, you have like b is equal to w sub 0, w sub 1, all the way out to, we have in the combinations up to w sub n, and then we have followed by w of n plus 1 all the way out to w sub 2n, and we have 1 over the square root of 2 pi, 1 over the square root of pi cosine of x, all the way out to 1 over the square root of pi cosine of nx. And then we have the other portion, we have 1 over the square root of pi sine of x, 1 over the square root of pi sine of nx. And now, so we have, in terms of application of the orthonormal basis, okay, we have g sub x equal to the inner product of f and w sub 0 times w sub 0, and so on. And we have for the coefficients, you have a naught, a sub 1, a sub n, b sub 1, all the way out to b sub n. And for g of x in the equation, so we have g of x is equal to a naught over 2 plus a sub 1 cosine of x, and anything that follows to be of the form where we have n to be an integer, and we have the order to be represented by, at least in the realm of the cosine terms, we have a sub n cosine of n times x, and for the sine we have b sub 1 sine of x all the way out to b sub n sine of n times x. So the coefficient of the angle and the subscripted variable will represent the same variable. And we have, okay, so the foundation for what we have with a naught, a sub 1, all the way out to a sub n, okay, we have just in the foundations we have with the Fourier integrals, okay. And now, for what we have with this function, g of x, okay, it says that this function is going to be the nth order Fourier approximation of f on the interval which is closed between 0 and 2 pi radian. And like Fourier coefficients, this function is named after the French mathematician Jean-Baptiste Joseph Fourier. And now just a case of Fourier approximation. And we have on the interval, again, closed between 0 and 2 pi radians, the least squares approximation of a continuous function f with respect to the vector space is spanned by 1 cosine of x to cosine of nx, and then we have the sine of x all the way up to the sine of nx is going to be, again, the function where you have a naught over 2 plus a sub 1 cosine of x, and you have your series of cosine terms, okay, spanning out to a sub n cosine of nx, and then we have followed by the sine terms where we have the first of these, we have b sub 1 sine of x, and the last we have, in general terms, at b sub n sine of nx. And we have where the Fourier coefficients, a naught, a sub 1, a sub n, b sub 1, all the way out to b sub n are as follows. And they can be obtained by integration. And these are a bit complicated, especially if you have just the right function f of x for, you're going to have, in some of the cases, especially probably most of them, you're going to have various applications of integration by parts. And we have for a naught, so we have 1 over pi times the integral of f of x dx, okay, as x goes from 0 to 2 pi. And then we have for a sub j, okay, and this will be the coefficient of what we have for the cosine terms stringed on out. And a sub j is equal to 1 over pi times the integral of the function times the cosine of j times x dx as x goes from 0 to 2 pi, and j is going to be a natural number. And also for b sub j, that is equal to 1 over pi times the integral of f of x times the sine of jx dx as x goes from 0 to 2 pi. And again, j we have with the natural numbers, or what are referred to often as the positive counting numbers. Now, just an example here. It says to find the third order Fourier approximation of f of x is equal to x, again, inside the closed interval between 0 and 2 pi. And, okay, and from the theorem, okay, so we'll have our 1/2 of a naught, and then we have our terms in the cosine, where we have a sub 1 cosine of x plus a sub 3 cosine of 3x. And for the sine terms, we're going from b sub 1 sine of x to b sub 3 sine of 3x. And the reason for this limitation is because we are looking at the third order Fourier approximation. And okay, now you're going to have these integrals laid out. And for a naught, that is going to be 2 pi. A sub j, working these items out, that will come out to 0. B sub j, we have at negative 2 over j. And again, so a naught, again, in the function, you're going to have a naught at 2 pi divided by 2. And so that is going to come out to pi. And then we have whether subscripted a terms or a coefficients. Okay, all of these are going to be negligible thanks to the integral regarding a sub j. But now for b sub j, we have negative 2 over j. So like b sub 1 will be like negative 2 over 1. B sub 2, we have negative 2 over 2, which is negative 1. And b sub 3 is going to be negative 2/3. And just substituting what we have here. Okay, so the first term, a naught over 2, that's going to be pi. And then we have for a sub 1 cosine of x all the way out to a sub 3 cosine of 3x. Those are going to be negligible, okay, thanks to, again, the integral of a sub j coming out to 0. But for the sine terms, we have for the coefficients in reference to b sub 1, 2, and 3, okay, we're going to have negative 2 sine of x minus the sine of 2x minus 2/3 of the sine of 3x. And, okay, and so we have here, okay, we just have the graphs, okay, and it says that the figure compares the graphs of what we have for f and g. Now, just looking at how we arrived at these integrals, and I'm going to provide a bit of a refresher. And for what we have, again, so we have f of x equal to x as x goes from 0 to 2 pi. Okay, and for a naught, you have 1 over pi. And we're integrating f of x dx as x goes from 0 to 2 pi. And again, f of x is x. Antiderivative becomes x squared over 2. And with x going from 0 to 2 pi and integrating. So we'll have 1 over pi. And we have times the quantity, so we have the square root of 2 pi over 2 minus 0. And that's going to be 1 over pi times what's going to end up being half of 4 pi squared. In the words, you'll be looking at 1 over pi times 2 pi squared. And in this particular case, you will have pi squared to reduce. And so we end up with 2 pi for a naught. Now, for what we have regarding a sub j, okay, so we have in the spread, again, your f of x is going to be x, and you're looking at integrating over x times the cosine of jx dx. And just looking at what we have with the integration by parts, okay, again, just a refresher, So again, have the integral of u dv is equal to u times v minus the integral of v du, or uv minus v times the integral of du. So just looking at what we have with, say, setting u equal to x and dv, have that as the cosine of jx dx. So du is going to be dx. Again, we're taking the differential. Antiderivative of the cosine of jx dx is going to be the sine of jx over j, or 1 over j times the sine of jx. And for u times v, so we have x over j, sine of jx, and we have minus v times the integral of du. And so we have v, we can just draw out the variable rational coefficient, which we have 1 over j, and we have times the integral of the sine of jx dx. Okay, so we still had the first antiderivative. Now we got minus 1 over j, and the integral of sine is going to be negative cosine. And in this particular case, we have negative 1 over j cosine of jx. So for the integral of what we have here, we got the result to be x over j sine of jx plus 1 over j squared times the cosine of jx, okay, followed by the constant. And taking this over to what we have with the integral, okay, as x goes from 0 to 2 pi. And so we have in the setup, okay, so at 2 pi radians, okay, now sine is going to be 0 and cosine is going to be at 1. So right now we got 1 over pi times the quantity. And with the upper limit at 2 pi, we got 0 plus what's going to be 1 over j squared. And any multiple that is going to be a natural number multiple of 2 pi is going to have it where cosine is 1. So we come out to 1 over j squared. And at 0, okay, sine is going to be locked in at 0. And the cosine of 0 is going to be 1. So we have collectively, we have from the upper limit, we have 0 plus 1 over j squared. And again, at 0 radian, okay, we have 0 for the sine, and what's going to be 1 over j squared for the cosine, but I'm going to be distributing subtraction. So you're going to have 1 over j squared terms to cancel. So it's going to turn out that for a sub j, okay, that is going to be equal to 0. And so for any natural number subscripted value, we'll have for the coefficients, we have a sub 1 equal to a sub 2, all the way out to a sub n is equal to 0. Now for b sub j, we're looking at the closed interval as x goes from 0 to 2 pi of f of x times the sine of jx dx. And okay, now with the integral of x times the sine of jx dx, so again we're looking at integrating by parts. So again we have u equal to x, and du is equal to dx, and we have dv is equal to the sine of jx dx, and the antiderivative of sine is going to be a negative cosine term. So we have negative 1 over j times the cosine of jx, and following through, okay, so uv translates to negative x over j times the cosine of jx, and then we have subtracting a negative, which is going to translate to plus 1 over j times the integral of the cosine of jx dx, and the antiderivative, we have 1 over j sine of jx, and following through, we're going to have the result with the terms negative x over j cosine of jx plus 1 over j squared sine of jx plus c, and then just transporting what we have in the numerical integration. So again, at 2 pi radians, okay, we have cosine is going to be at 1, whereas sine is going to be at 0. And so right now we got 1 over pi, and then filling in 2 pi for x, we have negative 2 pi over j cosine of 2 pi j. And we're going to have, okay, for x at 0, okay, again, sine goes to 0, and then we have with the variable coefficient, if I set x to 0, well, even though cosine of 0 is 1, well, 0 times 1 is still 0. And again, sine of 0 is 0, so there is only one non-negligible term, and this is from setting x to 2 pi and applying to the very first term consisting of cosine. So that part reduces to negative 2 pi over j, and multiplied by 1 over pi will come out to negative 2 over j. So that is what we're going to have for b sub j, and for what we have with our natural number subscripted values. And we have for the coefficient terms, we have b sub 1 is equal to negative 2 over 1, which is negative 2. B sub 2 is equal to negative 1. B sub 3 is equal to negative 2/3, and so on. Okay, where we have along the lines of b sub n is equal to negative 2 over n. And we have that order n is equal to 3. Okay, so just filling in. Okay, again, so g of x is equal to a naught over 2. And again, we had that a naught was already equal to 2 pi. Okay, and so for 2 pi over 2, that goes to pi. And again, all of our a subscripted terms, okay, all those coefficients are negligible, so we will not have any cosine terms. But for what we have in the sine coefficients, okay, would the variable b. So b sub 1 is equal to negative 2, and this will be in reference to negative 2 sine of x. B sub 2 at negative 1, so we have negative sine of 2x. And b sub 3 at negative 2/3, so this will be minus 2/3 of the sine of 3x.